Alright, um, welcome to another video. Today we're going to be talking about um some wintry potential for next week, along with the potential for a few severe weather events. The severe events that do look possible next week will not be major events. They won't be something to look over though, as they will definitely be something to watch. But first off, we're taking a look right now at a snow squall warning that we have in Wisconsin with a snow squall currently. We have DBZs of 30 to 40 DBZ right now. Um, so that is very interesting. Um, there's other areas of this that are probably going to get snow squall warned at some point too. As we transition into pivotal weather here in a second, let me just transition this over. We're going to be talking about um, the potential for snow squall, and then of course severe weather potential. Um, let's go first off into the snowfall. So here's the latest HRRR run. It doesn't really initialize very well, so I wouldn't trust it that much. Here's 22Z, 23Z. We have a low pressure that starts to deepen a lot, and we start to see a pretty good snow squall go through places like Illinois, Michigan, Indiana, maybe Iowa if they can get cold enough. Minnesota and Wisconsin. We could be seeing pretty not ideal surface conditions with the squall as well. And we're probably going to see we'll probably see snow squall warnings issued for some areas. Let's look at the gusts off the squall. There's the system right there. And we see you get widespread gusts of 40, 50 mile per hour, which could create some brief blizzard conditions. I don't know if there's a visibility thing on pivotal weather. I don't think there is. Yeah, I don't think there is, but we can just look at the little temp advection here for a little bit just to see very cold temperatures. And there's the squall just moving through right here as well. If we want to look at the 3 Cape with this, you can see there's actually some 3 Cape that comes down with this, and this could provide a more substantial snow squall for some areas like Michigan there. We'll take a sounding here. It's a little bit contaminated, but you can see here you actually have like a little bit of instability with this, and as well pretty good snow. So you might see some very heavy snow. Not might. You probably would see some pretty heavy snow rates. Maybe an area could get like maybe an isolated amount of thunder snow, but I don't think that's gonna happen. Um, well yeah. Now let's go into next week. There could be some severe weather. First, we're gonna be talking about the NAM model for next week. So we see that this trough kind of comes down. We see a new trough kind of come around. This right here, this is going to be the lead wave for a winter storm across some areas along with severe weather, and it's going to eject into Texas in there. And as you can see here, it merges with another wave, and bang, you get trough ejection across some areas. Now the NAM I think is overdoing the cap with this event a bit. There probably will be some sort of cap, but it's not going to be this strong. It has negative 100 all across the warm sector, which in my opinion is just unlikely to happen, which might be the cold bias hurting it a bit. But as we can see here, it has moisture getting all the way up into Illinois, places like that, so there might be a severe weather event up there the next day. Probably not. Probably will be. Looking at Arkansas at 6E though, NAM has a pretty good environment. It's just got a nice warm nose right there, which is going to help migrate things. Now, I think the NAM is going to be the model that is really just overdoing the cap. So that's just my opinion on this. Take a look at the photographs. We have some pretty good photographs, especially across Louisiana there. We see Arkansas. There will be some. The NAM photographs have a lot of veer-back veer with them in the mid-levels, which can help the storms, but make them a little bit more cyclic as well. And you can see the surface instability gets all the way up into like portions of Missouri as we get to 6C. So that's going to be very interesting. A lot more veer-back veer up there. The name does typically have a lot of veer-back veer though as well. And veer-back veer is basically when the sounding goes up and then back down or loops around like that. You like veer-back veer in the upper levels though, because it kind of vents the storm out a little bit. Here's the Canadian. You can see the wave right there. It gets pretty strong here. It merges with another wave, and bang, there's your trough ejection. The Canadian doesn't have it being as significant of a trough ejection, but the Canadian does actually have thunderstorm development, which is something the NAM does not have. Looks like it develops thunderstorms around 3Z and along the dry line there. Let me just look at this here. So yeah, why is Oklahoma so cold? That is weird. I'm pretty sure this is the only model that does that. Yeah. So it's coming in with the very unrealistic solution that Oklahoma gets so cold that you're not gonna see anything. What is this? What? What is happening here? I don't know what's happening here. There's not much of a wind shift. What? That is weird. Random, maybe a cold pull from an MCS? Is there anything though? There's nothing. That's interesting. But the RDPS shows a pretty stout surface cap at this point, but it's not elevated, so you probably could see some severe potential, especially potential for damaging wind gusts based off the kind of the V profile you have here, and large hail as well, maybe. Further south as you go into Arkansas or more Texas, we have more of a warm nose there. Arkansas though is looking pretty interesting with the dew points, and yeah, there you go. Arkansas off the RDPS looks pretty significant. If this solution were to occur, I mean, you have meager low-level lapse rates, but if you already had sustainable convection, given that you have a hodograph looking like this, and you have pretty strong shear right there, you probably would see some severe weather. I don't think I think the saturation in the low levels is a little bit overdone, so you'd probably get more of the temperature doing like that. So you might have a little bit less instability in the low levels, but you would have a lot of instability, not a lot, but a decent amount of instability as you get up throughout the sounding. It's not going to be a super skinny K profile, but it will be enough. Let's take a box sounding across southern Arkansas. Alright. Very similar box sounding to the plot sounding I took. A lot stronger flow. Pretty solid instability. Looks like you have a warm nose still at this area. It is on the verge of becoming elevated, but isn't. You have a pretty decent hail growth layer right in here as well. So that would probably provide potential for some large hail, damaging wind gusts, and tornadoes given the profile. Arkansas does get convection, and then at 60 we start to see the convection get better in Oklahoma. Arkansas still has a better dew points though for some reason. There's a random warm nose there at 850 millibars. That's interesting. You can see here the moisture convection though is getting pumped out of the Gulf of Mexico. And I feel like this is a more realistic solution than the NAM. The NAM just caps it out way too heavy everywhere. But yeah. That is a gross sounding right there. Oh my. But the NAM definitely does convect stuff in Arkansas there, and that would be a severe risk for sure. If it convected it, and probably more of an all hazards type risk. As we get further into the night, we see the low level jet stay pretty much the same, but we get the 500 millibar winds to get a little bit stronger in portions of Oklahoma, and the speed max gets a bit stronger as well, and we start to see dew points really start to advect into portions of the Midwest. Let me go over to that sector. We'll go to the Ohio Valley here. The NAM has them a lot further south, while the RDPS has the I didn't mean to click there. Well, the RDPS has the moisture advection being more north. You can see bang. I think the RDPS might be the more realistic solution with this. I mean, if we look at the GFS, it has it pretty similar to the NAM, actually. Except it goes a little bit further north as well, so I think probably the more realistic solution. Let me check the UK Met. Yeah, it has 50 dews all the way into Illinois. I don't know if that's a little bit too much aggressive. Might be a bit too aggressive. So I think a general cutoff line for the warm front at this point is probably correct in, like, central Illinois. Given the models, I mean, the Canadian and the RDPS look kind of similar. Yeah, pretty similar. we'll take a sounding up in like St. Louis, Missouri at 6E. We'll see what it looks like. And we have a warm nose, but that would definitely be favorable if you can erode that EML. You would definitely have more of a threat later on in the day. I'm liking that the surface winds are pulling up a lot of moisture at this point. That is something that is pretty interesting. Now, looking at the UK Met, this goes out to 12Z on the Thursday, so we'll look at that. We see the wave get kind of ingested into the other wave, and bang, we start to see the short wave kind of really get going there. We get along here, it goes into Illinois. We start to see a severe threat in Dixie. Oh, oops. And then we have another area of flow there. We have potential for an isolated severe event on Wednesday, but it's not looking very likely given that the model guidance varies on the type of warm sector we have. And the UK Met shows a really solid trough the next day, but it delays the trough by a day and has the moisture return not being so good. So that's minus with it. Now let's go stop it at 18Z on Wednesday. We're gonna take some soundings here in Texas. Pretty solid stuff. This run has a lot less of an LLJ than the previous runs, or low-level jet as we call it in the weather community. The last run, if we took a sounding in like this area, has a stronger low-level jet, which is very interesting. Big bang. A stronger low-level jet by 7 knots, which makes a big difference in weather. And that 3 kilometer, it's stronger by against 7 knots. You get a bit more deep layer shear this run, so you'd probably have more of a hail-producing type storm this run. Given that you have more instability and more overall deep layer shear. You see convection already start to go. At this point, the soundings still look pretty decent. That's a really good wind profile, but previous runs took it another previous runs had slightly more low-level shear, but the previous runs had a higher cap, and this run kind of compensates for that. So you'd probably get a higher severe risk with this run. Get a pretty decent hail growth layer there in blue. The lapse rates in the low levels for this event have not been great from surface to 3 right here, but they've been really solid in the mid levels, which is gonna color in blue. They've been solid within kind of this range throughout the whole event, which is very interesting. And then along with that, the hodograph, this would probably favor discrete convection, given that you have a lot of backing of the winds in the low levels, and a hodograph that is in between streamwise and in between crosswise. Crosswise is like more like that, and then streamwise is more like that, so it's kind of in between the two. But yeah, we have pretty good deep layer shear and pretty good effective shear as well. The low-level jet this run, though, like I said earlier, it's not as strong. The previous run had it being more widespread and a lot more strong, so places like Dallas had a really good LLJ, but the instability wasn't as good. Now this run, places like Dallas, if we take a sounding all the way up there, you get soundings like this. This would be more of a big-time hail sounding and a big-time wind sounding more than anything. If we do take a box sounding, though, where the LLJ is more prevalent there in central Texas, near Houston, we see a pretty good wind profile. Not the best, but it's definitely good. As we go into central Arkansas there, we see a bit of a warm nose there, but we see a pretty good wind profile as well. So we have models agreeing that we have a pretty good wind profile in Arkansas. Let's just look at the GDPS just to see. Yeah, pretty similar, except the warm sector's a little bit further south. Let's go further south in Arkansas. Yep, definitely very interesting to see that. Let's go to 6C and see what we have in Arkansas. So we have 65 dew points getting into central Arkansas at this point, but we have a stronger cap. What about the Canadian? What does it show? So at this point, the Canadian shows pretty similar environment to that plot sounding I took. So you start to get more capped out at 60, which doesn't surprise me. You're probably going to have more sustained convection ongoing at this point as well. The low gets down to 999 millibars. You know what this run has? This run has a way weaker. This run has a weaker low than the last run, so that's probably why the severe weather isn't as significant as the previous run. Okay, that makes sense. But as we see here, as we get into 12Z here, the low speeds off to the north and east, and we start to see the warm sector really get evect further northward. Here's like the 12Z New Orleans sounding, a really good wind profile, a very excessive EML. Not sure if you would recover really too much after that. We'll take a sounding in eastern Arkansas 12Z. That is supportive for tornadoes right off the bat in the morning. That's interesting. There's a small area there in like central Arkansas. Yeah, there's a small area that the UK Met paints that you would get tornadoes off of in the morning, like right here. Take a box over it. Yeah, this is not a favorable box sounding for tornadoes, but it's favorable for wind for sure. So you probably would have a damaging wind risk. Oops, did not mean to go over here. You probably would have a damaging wind risk in place. As we get into the Ohio Valley, we start to see forecast soundings up here at this point start to show an instability, start to show some instability, especially southern Illinois. We get 60 dew points to get all the way up there. And then we get to 18Z, and we start to see really anywhere with these higher end dew points like this. Could see severe potential with something like that. Something I can hear all the way up in there. And take a sounding right on the surface low, you see more not really backed winds at the surface, but more southwestern winds at the surface. You have a pretty solid hodograph, good low level instability, pretty good lapse rates, and that's pretty typical of cold core events. As you typically have that stuff, you usually have really strong deep layer shear. The low level flow isn't meager, but some of the time it's lacking a little bit. As you can see here, the low level flow in Kentucky is not lacking at all, but there's not going to be a severe risk over there due to the fact that the instability is just not there. If the UK Met was right, you would have a severe risk though in Tennessee. See here, looks like yeah, you would have one into Kentucky and Tennessee right there, but the severe risk is going to be too significant. As you get further south, the winds back a bit more, so northern Mississippi would have a higher hodograph but less instability. We'll take a box sounding in places like here, and we see pretty solid hodograph with SRH values of 200 to 300 there. We also have a pretty good area of instability, especially for the box sounding size, with mixed layer cape of around 750. And then we also have the keep of 600 and lapse rates in the 6.6.5 range. Low level lapse rates are not the best, but they're pretty decent still. As we get into southern Mississippi, as we take a point sounding, we see here, again, the hodograph is looking really nice. The shear overall is low, but it'll get the job done given the fact that you have decent instability across the warm sector. You see the theta E, you have 340 Kelvin across portions of Mississippi and Louisiana. As we get into 0Z, we see the environment start to get less moisture, of course, but there probably still would be a severe threat at this point. Just how much of one? As we get further north, the severe threat would probably transition with a cold core event up in Michigan. Now that wouldn't be severe at that point, I don't think. Yeah, it doesn't look like you have enough dew points up there to make that a severe risk. But that probably would be a thunderstorm risk up there. Yeah, your theta E is really lacking. As opposed to 18Z, you actually had a theta E pulsar right here, and you need like light green theta E colors to get instability. Like, yeah, there you go. There's your instability. So you don't have any light greens up there. So it means you won't get any instability. Rather, only really in the most unstable layer. As we get into the next day, the UK Met paints a picture where we have a lot of moisture in like portions of Florida, which may give you a brief severe threat as well. And then 12Z the next day, it doesn't show a warm sector at all. The Canadian doesn't. The Canadian has a really small warm sector. It gets a bit bigger, and the Canadian delays the event by a day and has it in like central Georgia. Well, the GFS has the event kind of this day, and then transitioned into this day, and the Euro has the event this day and then this day. So the timing and location for a severe event on Thursday and Friday is very off right now. And yeah. Before I go too further, I'm going to show you the SBC outlook. Day 4 through 5, there you go. There could be severe weather across the Carolinas. The potential for thunderstorms in the Carolinas and Gulf states. Tuesday could be an isolated severe threat. An isolated severe threat on day 4. Day 7 through 8, they mentioned potential for a 15% risk, but the timing is not really good right now. But let's look at the Canadian now. Here's the Canadian. As you can see here, pretty similar. Bang, 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 there you go. You see the trough eject into Illinois and places like that with, looks like convection along the front there. Then as you see here, this other trough is delayed with the ejection, which is possible because a lot of models show a delayed ejection, which causes the severe risk to be a little bit less. As you can see, another trough there. And then after that, a pattern change in a very quiet pattern looks likely. Let's go look at the dew point loop here. Well, that's the Euro. That's the wrong model. Whoops. Let's go look at the dew points here. You have a low pressure there. That's bringing snow to the Midwest today. Then you see the moisture kind of go right back up into the Gulf of Mexico, and we start to see a severe risk at 0Z on Friday. The Canadian wants the severe risk to be further east and pretty significant across Arkansas. Wow, look at that photograph there. Along with some pretty decent instability values, but lacking surface lapse rates again because of a email that gets partially eroded. You can see here though, if we take a box sounding right there, we'll take a box. You get a really solid photograph. Your instability, it's cutting the line of being elevated. The elevated line is like right there, and it's like right on it. Let me use a different color so you can see it. Let me go use blue. So the elevated line is like right here, and it hits the elevated line. So this is a borderline elevated sounding, and an elevated sounding is not as prone to producing tornadoes. But given the fact that you do have a lot of instability still, I do think it could potentially produce a tornado. The main threats, though, with this day are probably going to be large hail and damaging wind gusts. The next day, we start to see flow go all the way into Illinois, as well, with moisture getting up there. That's a not bad 12Z sounding. 12Z in, like, northeast Louisiana there, Monroe, Louisiana. Not bad, but not really significant. At 18Z, we start to see the flow get going, and we start to see some areas of instability get all the way up into Illinois there, or maybe not up into Illinois. Let me just see. You get Calvin up there? Oh, okay, so this run does not show a cold core threat in Illinois, but there have been runs that have shown a cold core threat all the way up into Illinois. It only shows the instability advancing into Indiana. This run does not. This run shows a pretty good Dixie threat too, with 340 Calvin in some isolated areas. Small photograph, smaller than most of the models show, but good enough deep layer shear and effective shear to get it done. We also have pretty solid amounts of shear in the low levels. They're not great though. Good low level instability, 83 3 cape. You have D cape pretty high of almost 1,000, which would cause a pretty significant damaging wind threat. And then you also have a decent thermal profile. It's not the greatest thermal profile ever though. As you get a little bit further north of the Mississippi on the GDPS, you see the overall shear get a little higher, but the overall thermodynamics get a little lower. And the low pressure system is actually further south this run, so that's why the Illinois threat is not as prevalent. Again, that's just going to bring a winter storm too to portions of the area, even though we've been mainly focusing on the severe weather aspect. And then you can see there, the next winter storm goes up. It mainly is it's another little southern clipper, and then we get another little winter storm, so it's definitely possible next week. Now let's go on to the Euro model. So the Euro model next week, we start to see that bowling ball trough get in there. It starts to eject. We get the flow to go bang right around here, and there you go. There's northeast Texas sounding. Not bad, but there's a really good warm nose in the low levels, so that would prevent more stable convection. The Euro shows shows the kind of being a little bit further south. So there's potential for the trough to be a little bit further south and limit the cold core. The Euro has a faster trough ejection with this trough, and it shows more of a significant severe risk across like Louisiana and Texas, as it brings up ample amounts of moisture, and then that trough goes and it goes up and out of there, and no more severe weather. Actually, that last system might bring severe weather if the Euro is correct. Let me just see this here. Is there enough moisture? No. Okay, so that would be more of a winter storm. Oh no, just some rain. Okay. Let's go out to hour 81 on the Euro. So at this point, we see a broad warm sector with 50 dew points in green, darker green there, all the way into Illinois, Missouri, and then extending down in places like Georgia, Alabama, Florida, Mississippi, Western Tennessee, Arkansas, Oklahoma, Texas, and Louisiana. So a relatively large warm sector at that point. We see more veered surface winds in portions of Texas there. Looking at the photographs, they're not bad, but you have a lot of capping in the low levels with a significant amount of warm nose layer. At that point, maybe 18Z is a little bit better. I don't know. Maybe it's a little bit worse. We'll see. Yeah, it's worse. Okay. Let's go to 0Z and see what it looks like in Texas. Looks like you have more backed flow in the low levels. Looks like your surface cap's a lot higher. It's a nice wind sounding with the V shape there. If you go look in northwest Louisiana as well, it's pretty capped. Southern Arkansas, that's not so capped. That'd be more of a favorable profile. Let me go look at the Cape on the Euro. So, widespread Cape. Problem is the mixed layer SNH. It's very high. I mean, it's not so high in East Texas right here. Yeah, that would be more of a severe threat with that profile. Some areas it gets very high at 0Z. Southwest Arkansas, though, it's not that high. Yep, that's a lot more of a favorable profile there in southern Arkansas. If we go to 3Z, and we start to look at the precip there, we start to see the dry line start to convect. It convects a little too late because the warm nose is way too strong. I wouldn't really trust a long-range model's convection, though. As you can see here, pretty solid stuff still in Arkansas at that point. As you get to 6Z, we start to see the everything move further east into Arkansas again. And the veer back veer is very catastrophic with that sounding. What about a little bit further north? Is it still super catastrophic? Oh, that's a problem. So the Euro has a problem where you get a really bad veer back veer, and it goes all the way over 0 to 1 kilometer vector. That would just kill storms and split them to all heck. That's nice, Euro. Okay, that's not so bad of a veer back veer, though, a little bit further north. The next day, I already see solid stuff at 9Z, and as you get to 12Z, we already see some pretty significant stuff too. And then as you get into the 18Z time frame, of course, you start to see the dew points and the Kelvin, the 340 Kelvin really get up there. And you start to see starting with 2000 Cape off the Euro and high 70 dew points or high 60 dew points and really solid lapse rates. This would confirm to more of a damaging wind and hail threat, but you can't rule out tornadoes given the low-level profile as well on the Euro. Now let's go into the winter storm portion of this. Let's go into the winter storm portion of this. I haven't checked the GFS yet with the 18Z run, but I think we're going to be running short of time, so we're just going to check the winter storm portion of this. We'll go to hour 180. Currently, snow, we have a few inches expected, with 4 to 5 inches expected across Illinois. Based off recent trends, we have a couple ice storms that are possible. One that hits northern Illinois, Indiana, or Iowa, Indiana, Michigan. We have another one that goes for a more southern track as well. Looking at the Weather Prediction Center site, you can see here's their front map. Here's Monday at 12Z. We see the severe weather risk. Tuesday 12Z, a very heavy winter storm across portions of Iowa into that area, and potential severe weather across portions of Illinois, Indiana, Kentucky, and further southward. Wednesday at 12Z, snow and ice in Texas. Thursday at 12Z, snow and ice in Illinois and places like that. And a severe risk potentially in Mississippi, Louisiana, Arkansas. Friday, if the system is fast, it will go all the way into portions of the New England area. The QPF over the next few days, it just lights up across this area. Very significant flash flooding is possible. You also see the winter weather index. Day 4, we have a risk across the northern plains. Day 5, we have the risk across the northeast. Day 6, we have a risk across the southern plains into the Midwest. And day 7, it's from the plains all the way into the Midwest as well. That will do it for this one. This was a very long one, so we'll see y'all in the next one.